Hello and welcome. In this video, let's learn about breadth first traversal or level order traversal of a binary tree. So in BFT, starting from the root node, we explore all the nodes at the present level prior to moving on to the nodes at next level. So it just means that we start from the root node and then traverse the next level and then the next level. So in this example, the output which we are expecting is 1, 2, 3, 4, 5 and 6. This is how we traverse using BFT. Now let's look at the algorithm. So the efficient algorithm here is taking an queue. Queue is a FIFO order. So queue follows a FIFO order, first in and first out. So the algorithm is take an empty queue and initialize with root node. So we have taken this empty queue here and we are going to initialize with root node, which is 1. Now iterate through a loop until the queue is not empty. At this point the queue is not empty. We still have one element here. So we are going to iterate through this loop. Pop the element from the queue. Yes, I'm removing it and print its value. So the value of this node is 1. And then add its left child to the queue. The left child here is 2. And then add its right child to the queue, which is 3. Now we'll iterate again through this loop because the queue is still not empty. So I'm going to remove 2, print its value and add its left, which is 4, and then add its right, which is 5. Similarly, the queue is still not empty. So I'm going to repeat this process for 3. For 3 there is no left child, but there is a right child. So I'm going to add a right child here. Next is 4. I'll print this value, but there are no left or right child, so I'm not going to add anything here. The queue is still not empty, so I'll repeat the process for 5 and then for 6 as well. As there are no left or right childs for both of these, I'm not adding any. Now at this point the queue is empty. We don't have any more elements in the queue and hence we'll stop the algorithm, and this is how we get the output. And the time complexity here is O of 1, O of n, because we are traversing every node exactly once, and the space complexity here is O of n because we are taking the help of an queue here and we are storing each and every value of the node here. So the space complexity is also O of n. Now let us see how we can do this with the help of a code. In the previous video, I have already shown you how to create a node using Python. You can please refer to the video in my description box below. So here I'm going to create a method and I'll call it BFT, and I'll pass in the root node of the tree. Now, as I have said, I'll create a empty queue here. Now, if there is a root node, there is a possibility that the tree can also be empty. So we need to consider this edge case, and now we'll proceed. If there is a root node for this tree, then I'm just gonna add this root node here. So queue dot append root node. So here I'm initializing this queue with the root node. Then I want to iterate through a loop. So I'll say while queue. This actually means that while there is an element in the queue, then proceed the following. So while queue, what I'm going to do is I have to pop the element from the queue first. So I'll use a 0th index here because I want to pop the first element. So I'll pop the first element and then currently store it in a temporary node, which is current node. And then I'll print its value. its value is in a data attribute here, because we can see here the definition of a node which I described, data left and right pointers. So current node dot data, and then I'll append it with a space. Then if the current node has a left child, so if current node dot left, then I'll append this left child value or left node to this queue, and similarly if the current node has a right child, then I'll append the queue with the right node of this current node. So yes, we are done with the algorithm here, and all we have to do is we have to test it out if this works. So I'll add a print statement here. So BFT, and then all I have to do is call the method which we have just created, which is BFT, by passing in the root node of this tree here. So I've saved it and I've executed. Now we can see that the output is 1, 2, 3, 4, 5 and 6. So this is as simple as this, and thank you for watching. See you in the next video.